All right, let's keep going. We just went over protozoans and gross brain-eating amoebas, and let's get into something more pleasant. So here we have another type of protist, our algae. Most people think they're plants, so pretty obvious that they are the plant-like protists. And here we see kind of a cool arrangement of algae that are living as a colony, probably again grouping together to be more sturdy and also share carbohydrates through photosynthesis. Here's a picture of a really cool diatom, which I mentioned have really amazing geometry and almost looks like a bicycle wheel or something like that. And so just, yeah, really neat picture. Here's another really cool diatom that has this star shape. So stars are definitely complex geometric shapes. So it just shows that, you know, nature is not just kind of random and whatever, that we see these some really amazing mathematics to some of our organisms. This is a close-up of a diatom, and they actually make sort of glass-like structures, which the video you're going to watch this week does talk about. And here it does look like glass. It looks like stained glass, like a stained glass window. And again, just really incredible, you know, almost perfect types of geometry going on here. And here's a cool picture of a tiger swimming through a pond. And we talked about how sometimes this is okay. But in Unit 5, we talked about how, in some cases, if the algae is too thick on the surface, it can actually suffocate the organisms underneath and block the sun. So now photosynthesis is only happening on the surface and doesn't happen underneath, and thus there's no oxygen in the water over time, which is what I meant by suffocating it. But this kind of algae, I think this is natural. These are really thin-looking algae. I don't think this has that same problem. All right, the ones that are like fungus are called slime molds, which is kind of obvious because normal molds are a fungus. And here we see it kind of oozing off of this plant. Looks pretty gross. Here we see it almost looks like our circulatory system in the way that it's branching. And just kind of another weird story. I don't know, maybe about 15 years ago there was an outbreak of these slime molds in the south, like in Georgia and stuff, where it's really humid and there's a lot of moisture and stuff, and they were kind of growing onto people's, like, their deck or their patio and stuff. And they actually pulse because they when they pump and pulse, they're spreading nutrients. So maybe over here there's more nutrients, so they'll pump them to where there's less, and that is sort of like what our circulatory system does, where it pumps blood, right, and gets nutrients where we want. So as it does this pumping of nutrients, it pulses, and obviously that's going to look pretty weird. So people were kind of freaking out and thought they were kind of like aliens that were like invading and had come from outer space or something. And part of that was the pulsing, but also they would take a hose and like hose it off their deck, and then it would kind of fall apart, but then it would like regrow and keep growing and pulsing again. And they're like, oh my god, it won't die and whatever. And people, yes, there were reports that people thought they were like some kind of extraterrestrial alien life had landed to invade the Earth. And here's another weird one. Kind of looks like a whole bunch of ladybugs to me. So, you know, just very different looking slime mold. All right, as I told you earlier, we're always going to end with ecology because, as you know, ecology is very important, not just to me, but to life on Earth, and this was a lot of what I studied in college. So we're always going to wrap up each kingdom with why are they relevant? Why are these organisms important to life itself? And basically, protists do everything. All the important things can be performed by different types of protists, and basically animals cannot survive without protists. If protists didn't exist, I don't think really there would be animal life on Earth. Maybe other forms of life, but probably not animals. So we need them. So first of all, they're incredibly important for nutrient cycles. They're some of the world's most important producers, and it's believed that the algae in the ocean is creating half of the Earth's oxygen, which we have talked about before. And if you recall, I've said it a few times, even small temperature increases is actually causing the algae to die, which is why we need to take global warming extremely seriously and start reducing our use of fossil fuels, which increases global warming, and start shifting towards renewable, cleaner forms of energy like solar panels and windmills, which do not create that kind of pollution, so that we can protect our algae and our producers. So here's a bunch of diatom algae. And then over here we have a weird slime mold, and they function as decomposers, and they get rid of nasty stuff and recycle the nutrients back into the soil and back into the ecosystem. And if you remember from Unit 5, I said that producers and decomposers are always keystone species, and the stability of an ecosystem absolutely relies on the health of its producers and decomposers. And that does not include consumers or what we call animals. So these organisms are crucial for life on Earth, and then animals can exist and survive. Let's keep going. They're also part of food webs, and so obviously food webs are important, and so we want to make sure that algae and other organisms are available at the lower parts of the food web so that more advanced organisms can survive. And some protists make up plankton, which is the foundation of our ocean food chains. And these are not protists, these are little micro animals. I was having trouble finding protist plankton, so I just put in sort of animal plankton. However, I did find a picture of plankton. So at this point, normally I ask like a bonus question to see who's been paying attention in class, and I would say, okay, so what protist that I talked about earlier, what kind of protist is plankton? And maybe think about it. If you've been watching these videos in order, then hopefully you remember. I think it was the first or second video on protists. So what it appears to be is that plankton is a euglena. So if you remember, euglena have the red eye spot for detecting light. The eye spot is generally connected to their flagella, which we see here. And it kind of, the eye spot tells the flagella where to go so they can go to sunlight. And euglena also have this kind of oval shape. So it does appear that all along plankton was a euglena protist. All right, we also have some parasitic diseases. This is the dark side of ecology. Although it's good for them, it's bad for us and maybe other animals and stuff. So malaria is far worse than this one over here, and it can kill people. It's transferred by mosquitoes in Africa, and some scientists have created theories that half of all humans that have ever lived have died of malaria, and a large reason for that is because all human ancestors do come out of Africa based on the fossils. And so all our ancestors, regardless of what race you consider yourself to be, all our ancestors came out of Africa. And that's why some scientists think maybe half the humans that have ever lived have died from malaria in Africa. And then over here we have dysentery, which you may have heard of, and it is why you're not supposed to drink the water in some places, like in Mexico. And this is an amoeba that is in the water, and some of the local people have actually co-evolved and do not get sick. But if you are visiting, you can get sick, and that is because the amoeba gives you dysentery, which in common terms tends to give you bad stomach aches and bad diarrhea. I'm going to give you a little story to warn you about being careful when you go to these places and take it really seriously. And I was on a trip with some people, and we were actually being super careful the whole time. We were boiling our water to kill it. We were drinking bottled water only. We were, being really, really careful. Nobody got sick, so that was good. On our way out, there were 3 of us that had later flights at the airport, and we had to hang out at the airport for a while. And we figured the airport would be super safe because they've got all these people coming and going, and they could definitely get sued if it's found they're not taking care of their water and using safe water. So pretty sure we went to a Burger King at this airport and stupidly got sodas, and 2 of us, I think at least, got dysentery from the ice in the soda. And it didn't hit until we were literally about to walk on the plane. And then it was like, is this real? And then suddenly the stomach starts going, and my thoughts were literally, I'm about to start hours and hours of travel on a plane. This cannot be happening, and it did. And then I also had to do a layover in Mexico City and run from one terminal to another to make my flight, which did not help. And so learn from my bad experience, and be very careful, including water or ice and stuff at the airports, because I probably could have sued them in some kind of way. But at that point, I'm just trying to get home and not be sick. All right, we also have different forms of mutualism, which is one of my favorite topics. That's when both organisms are doing well together. And so coral have a mutualistic relationship with algae where they help each other survive. But again, when the coral bleaches, that's because the algae has died, which may be because it's gotten forced out, or it's just died because the temperature increases and the coral turns white. And then over here is a weird protist that looks like it's covered with hair, and it's actually helping with digestion inside termites. So this is why a termite is a termite. Otherwise, it would just be a weird ant. The only reason why termites can digest wood, as well as some other insects, is because they have protists like this living inside their digestive system. So again, without this protist, when you hear the word termite, it wouldn't mean what it means to us. They would just be a strange ant. All right, and then that's it. We have a little picture here showing some different protists living in a drop of water. There can actually be multiple organisms like this living in a drop of water. And that's part of what Leeuwenhoek, as I mentioned earlier, Anton Leeuwenhoek discovered this and found all sorts of organisms swimming around in the water that his village was drinking and cooking with and washing with and all sorts of stuff like that. So that was a pretty amazing discovery. So, all right, we're going to go on to fungus. And now we're